Welcome to Gradient Snack. In this video, we'll explore the mathematical foundation of gradient descent, one of the most essential algorithms in machine learning. We'll walk through the core concepts, visualize the process, and write a simple Python implementation together. Let's break it down. So gradient descent is an optimization technique used to minimize the loss function in machine learning. Simply put, it helps our models get better by iteratively reducing the error between predictions and actual values. Whether you're training a neural network or fitting a line, gradient descent is at the heart of the learning process. To understand gradient descent, let's break it into the math. In simple terms, we start at the initial point, calculate the gradient of a loss function, which tells us the slope, and then adjust our parameters, whether weights or intercepts, by a step in the opposite direction of the gradient. Mathematically, this is written as such. Now let's visualize this process. Imagine we are on a hill, trying to find the lowest point. We start somewhere on the slope and take a step opposite to the gradient, which indicates the steepest ascent. That's how we get to the bottom of the loss function, by always going downhill. As we compute the gradient at each point, the algorithm moves iteratively towards the minimum point. The size of the steps is determined by the learning rate. If the rate is too large, we might overshoot. If it's too small, converges become slow. The loss function is the measure of error. In linear regression, it's the mean squared error, MSE. The gradient of the MSE function tells us how much the weights need to change to reduce the error. The learning rate controls how big each step is. If the learning rate is too large, we risk overshooting or diverging. Mathematically, mean squared error looks like this. The learning rate controls how big each step is. If the learning rate is too large, we risk overshooting and diverging. If it's too small, we could be stuck in a local minimum or take forever to converge. Here is an example of convergence and divergence with different learning rates. While implementing gradient descent, there are a few things to watch out for. First, if the learning rate is too large, the algorithm can diverge, bouncing around without ever reaching the minimum, as you can see in the right. On the other hand, a very small learning rate can make convergence painfully slow, taking too many iterations, which is shown right in the middle. Feature scaling is also important. Features with different scales can slow down the learning process, and sometimes even make gradient descent fail to converge. To recap, gradient descent is a simple yet powerful algorithm that help us optimize machine learning models by iteratively moving toward the minimum of the loss function. By adjusting parameters like weights and learning rates, we can efficiently reduce error and train models. Next time, we'll dive into common optimization techniques like momentum or atom. Let's write a simple implementation of gradient descent in Python. Here, we'll fit a line to synthetic data using gradient descent to minimize the mean squared error. In the next few lines, I'll define the loss function, calculate gradients, and update the weights and intercepts. We start by importing the necessary libraries. We need NumPy for mathematical operations like arrays and gradients, and we need matplotlib for plotting the data and visualizing the results. Here, we are generating some synthetic data to demonstrate the gradient descent process. We start by creating an array of 80 evenly spaced values between 0 and 10, representing our input feature values. Then we define the true parameters of our model, weight and bias, that we are trying to estimate. And finally, we try to calculate the target y value using the formula y equals 3x plus 7, and also adding some random noise using RNG normal to simulate real-world data. After that, we initialize the model's parameters, weight and bias, with starting values of 0. These are our guesses before we start training with gradient descent. The goal of gradient descent is to update these values iteratively to minimize the error. After that, we define our hyperparameters So learning rate, which controls the step size, and number of epochs, which is basically the number of iterations. Next, we define the training loop, where we will apply gradient descent. So N stores the number of data points, in this case it's 80, and loss history is an array that will store the loss values at each iteration, which we'll plot later to show how the model improves. Next, we write our for loop, which is going to run 2000 times, which is the same number as our epochs. And inside that for loop, we define y hat, which computes the predicted y values using our current guesses for weight and bias. This is the linear model we are trying to optimize. And the error is the difference between the predicted values and the actual target values, which is also called residual. After that, we calculate the loss using mean squared error and add it to loss history. Then we calculate the gradients, which is the partial derivatives of the loss. We calculate gradient with respect to weight and gradient with respect to bias. And after that, we update our parameters using the gradients and the learning rate. This is where the actual gradient descent happens. We subtract the gradient multiplied by the learning rate from the current value of weight to move it in the right direction. And similarly, we update bias using its gradient. After that, we print out the learned values for weight and bias and compare them to the true values. And in the end, we plot the original data points as a scatter plot, and also we plot the loss curve over the epochs to show how the loss decreases as gradient descent progresses and the parameters get better. And this is the result we get after plotting the original data points and the fitted line, and also the loss curve over the epochs to show how the loss decreases. Thanks for watching. If you found this video helpful, don't forget to like, subscribe and share. Stay tuned for more bites of data science and machine learning on Gradient Snack.